The seas surrounding Sabah are known to have the richest marine biodiversity. The biodiversity of coral reefs and marine resources, mangrove and coastal wetlands, and seagrass beds is among the highest in the nation, if not the world. Borneo Marine Research Institute was established in 1995 as a specialized research unit for research and development in marine science and aquaculture. Our motto is Conservation and Sustainable Development of Marine Resources. We offer postgraduate programs at master's and PhD levels in the fields of aquaculture, marine science, marine biotechnology, fisheries science, and coastal and marine management. We are also involved in producing undergraduates in aquaculture and marine science. Located at the seafront with a jetty with berthing facilities for research boats, our research institute is well equipped with finfish and shellfish hatcheries, laboratories, and an attractive marine aquarium and museum. These are some of the advantages for education, research and outreach, and a coherent functioning of this Centre of Excellence. Universiti Malaysia Sabah is the only university in Malaysia with 2 on-campus aquaculture hatcheries. The Aquarium and Marine Museum is an important component of the institute, which is utilized for biodiversity education, research and public outreach. Visitors can have a glimpse of what lies beneath the waves, a display of ecosystems as complex communities of organisms and preserved remains of marine flora and fauna. We are equipped with several research boats and diving facilities for ocean studies. The Institute also consists of the Harmful Algal Blooms Studies Research Unit. The focus is on multidisciplinary research with the aim to assist the Sabah government in prevention, control and mitigation of harmful algal blooms. The Endangered Marine Species Research Unit focuses on the conservation of a diverse range of endangered marine species such as sharks, rays, marine mammals, turtles and humphead wrasse. For our niche research and development in aquaculture, the fish hatchery is the foundation of BMRI's aquaculture program. It is a place for conditioning broodstock and breeding them in captivity and producing fish seedlings. We have progressed from the first in the world hybrid garupa between the giant garupa and the tiger garupa species in 2006 by closing the cycle in 2016. The shrimp hatchery focuses on the research for commercially important crustacean species such as lobster, giant freshwater prawn, tiger prawn, and mangrove crab. In 2016, our hatchery has achieved a significant milestone in shrimp aquaculture research, where we have successfully bred the mangrove crab of Scylla tranquibirica. The crablets are important for commercial crab farming and to restore the natural resources through stock enhancement programs. Rakan Aquaculture is a unique program for knowledge sharing related to aquaculture between the university and industries. We are also committed to serve the community by way of developing human resources and welfare of the coastal community with an ongoing stock enhancement activity program. Through international networking, our institute has jointly established the UMS Kindai University Aquaculture Development Center, both at UMS and Shirahama Fishery Station, Kindai University, Japan. We will continue to forge networking and collaboration with institutions that share interest in our research programs. The UMS Borneo Marine Research Institute, committed to sustainable development of marine resources.
Selamat petang, salam sejahtera, Happy World Oceans Day and Happy Coral Triangle Day. I am Juanita, your moderator for this afternoon session. Terima kasih kerana bersama-sama kami sekali lagi untuk sesi ketiga Oceans Talks. Jika kemarin kita mendengar 5 penyelidikan daripada rakan sekerja saya di Institut Penyelidikan Marin Borneo, Universiti Malaysia Sabah, pada hari ini kita akan mendengar lagi 5 lagi penyelidikan dari rakan sekerja saya. Today with me, I have my colleagues, Associate Professor Dr. Teruyuki. Hello, Dr. Teru. We have Puan Wahidatul. We have Dr. Madiha. We have Dr. Nur Fatiha. And finally, we have Dr. Nazia. Welcome. Welcome to all panels, and thank you for taking time off of your busy schedule to be with us to share your research. For the first speaker, I would like to invite Associate Professor Dr. Teru. Let me introduce a little bit about Dr. Teru. So Dr. Teru is a phytoplankton and zooplankton ecologist. He is actually from Japan, and he had been with us since 2015. His talk for this afternoon will be on the harmful algae blooms. Okay, Dr. Teru, dipersilakan.
Okay, terima kasih, Dr. Juanita. Selamat petang, everyone. Today, I'd like to present something on the harmful algal blooms, and I'd like to share the screen. Okay. Do you see the screen now?
Yes, we can see the screen.
Okay. So today, the title of my presentation is Harmful Algal Blooms, and actually, I'm a zooplankton expert, but I recently branched into phytoplankton ecology as well. And I'm currently attached to the Unit for Harmful Algal Bloom Studies, or UHABS, in the Institute. So this is a typical scene of plankton sampling. What we do is we'll take phytoplankton or zooplankton samples using a plankton net that is of very fine mesh size. And we'll tow it under the water, and whatever that's collected at the end of the bucket will be used to analyze the sample. Yes, the person in the sunglasses is me during my younger days. And this is another scene of plankton sampling. You can see that we have to go through many seasick episodes. I'm very prone to seasickness, and sometimes I wonder if I have chosen the correct career. So we know that there are many issues that are facing our seas today. Ocean acidification, global warming, overfishing are some of the well-known challenges to the marine ecosystem. And more recently, there have been a focus on research on microplastics in marine ecosystems. And then there are HAVs, or harmful algal blooms. Harmful algal blooms have caused many negative effects, not just to the marine environment, but also to the people, to public health, and also tourism, and also the fisheries industry. So before I dive into what harmful algal blooms are, I'd like to explain a little bit about phytoplankton, because harmful algal blooms are a group of phytoplankton. And phytoplankton are very small. They are not really visible to the naked eye. So most of them are less than 10 micrometers, and they are largely categorized into diatoms, dinoflagellates, and cyanobacteria. So as we know, phytoplankton form the basis of the marine food chain, transferring the energy that is produced from photosynthesis up the marine food trophic levels. And in more recent times, we find that phytoplankton contribute to a large proportion of the dissolved organic material in the oceans that form a different route of energy transfer called the microbial loop. And so this is what phytoplankton play an important role in the marine ecosystem. So many harmful algal species are dinoflagellates, and they form what we call cysts. This is the dormant stage of the life cycle of the phytoplankton. And this shows the general life history of the dinoflagellate. When they form cysts, they sink to the bottom of the ocean, and they stay dormant for some time until favorable environmental conditions arise. And there's excisement, and they form this vegetative state. And at this stage, that's where they bloom in large numbers very rapidly. We call them phytoplankton blooms. So this is a natural phenomenon that can be found in all phytoplankton species. And some of them, for those species that cause negative effects, they are termed as harmful algal blooms. Yeah, so those algal blooms that have negative effects are called harmful algal blooms, and they affect many living organisms of the coastal ecosystems, from small organisms to fish to even people. I'm sure you've heard of the term red tides, where there's a discoloration of the water, seawater, turning reddish brown. And this picture is a very good example of how extensive a red tide can be. This is found off the coast of South Africa. Sometimes these red tides can form very large areas that can be even visible from outer space. On to more local areas. This is a red tide event in Kota Kinabalu. I wonder if you can see the boundary between the red colored water and the normal blue color water. Kota Kinabalu is prone to red tide events. It's not massive, but it frequently occurs. In Likas Bay, this is more recently, last year, May, we've experienced a major red tide event in Likas Bay that colored the water brown. We went to the bay to monitor the daily bloom formation of the species. And we found that the bloom was caused by this species, Peridinium. Cell abundance reached to the millions per liter. And this can be considered one of the major HAB event that we experienced in recent times. So HABs form due to a combination of environmental factors, one of which is the intrusion of anthropogenic nutrients from terrestrial inputs. And in Likas Bay, we have what we call the black water phenomenon, where every day there'll be some discharge of urban wastewater from the irrigation department. And so this is not a Photoshop picture. You can clearly see that the urban wastewater is being discharged into Likas Bay. And I think this is one of the reasons why there's frequent occurrences of HAB in Kota Kinabalu. I think this is also, even though it's not a large scale bloom, but it is very frequently we find blooms in KK waters. This is another example, recent bloom in near the Megatol River mouth. This is another species of HAB, Magalephidium polycricoides. Again, the extent of this bloom was not really that large. Beyond the mouth of the river mouth, there's no more, we cannot find any blooms. But nonetheless, these blooms frequently occur in KK waters. So why are they harmful? When blooms die out, the bacterial decomposition of large amounts of organic material depletes the water of dissolved oxygen. So that's why fish may die as a result. And some of these species produce what we call toxins or neurotoxins. And even in low concentrations, these species can be poisonous to animals and humans. A well-known effect of HAB is paralytic shellfish poisoning, or PSP. This is where when a harmful algal species bloom and get fed on by shellfish, which accumulate the toxins. The shellfish are not affected because they are invertebrates. They are not affected by the neurotoxins. But for someone who, if one were to eat the affected shellfish, they will get affected by the toxin. And this shows the global distribution of paralytic shellfish poisoning. We see a very drastic increase in the areas where PSP toxins were detected. 1970s were very few, and then in the 2010, it was much more cases. And these are some of the species that cause PSP: Alexandrium, Gymnodinium, Pyrodinium. These are species that also can be found in Sabah waters. And the symptoms of this toxic effect is tingling sensation, numbness, ataxia, meaning not able to walk straight, giddiness, drowsiness, fever, and rash. And in severe cases, this may lead to respiratory arrest within 24 hours of consumption. There's no antidote, and supportive therapy is the rule. So quite often we see in the newspapers, people stop selling shellfish due to HAB warnings. Number and size of HAB events is increasing in recent years. For example, in Southeast Asia, Vietnam, Thailand, and Malaysia, many HABs are formed by this species called Alexandrium in red dots. And in Philippines, the majority of the HAB event is caused by the species Pyrodinium, those that are found in indicated in black dots. And in Sabah, the unique thing about Sabah waters is that we experience all three major species of HAB blooms. So this is one thing that makes Sabah waters a unique place to study HAB ecology. Recent major HAB events in Malaysia. This is you can see the red arrows. They indicate those areas affected by HABs are mainly from Kota Kinabalu, Sabah. All right. And so at Sabah, we see frequently news on HAB effects on societal well-being. And they also cause economic losses to fisheries and aquaculture industries. For example, this is a massive fish kill event in Penang during 2005. The economic damage was more than 20 million ringgit of losses. And then more recently, February 2014, there was a mass fish killing in Johor, affecting many fishermen, and also one of the fishermen reported losses of 150,000 ringgit. And this is more recent. This is this month. We find that there was a bloom of Coclodinium species that caused massive fish kills in Penang and Kedah. So the economic effects are very tremendous. So many studies have been carried out using traditional methods of taxonomic detection of HABs. And the molecular methods of detecting HAB species are being developed at a rapid pace. But there's still the need for an early detection system for HAB species. And one of the things that we challenged was we worked to get together with the researchers, our collaborators from the National University of Singapore and Soka University, Japan. And we came up with a molecular technique that rapidly recognizes potential HAB species. So one of the advantages of molecular analysis is that we get the results very quickly, thus we can take actions more quickly before the bloom becomes well established. So this was our results show. We actually found or established a method for rapid profiling of the cyanobacterial communities from Sabah waters as well as from Singapore waters, and also rapid detection of profiling of phytoplankton communities, not just the HAB potentially harmful species, but also the total phytoplankton community is currently ongoing. So one of the advantage of using this min-ion method is that it's simple and direct. Sequencing and analysis of DNA is very portable. It's just a very small size machine, and it gives us direct, very fast results that lead us to analyze the results in just one day. So making it possible to take mitigation efforts. And also it's relatively cheap. And this is an ongoing study. We've so far found 40 genera and 46 species of planktonic and benthic cyanobacteria from Sabah and Singapore waters using the same method, the MinIO method. And we are planning to publish this in the near future. And one more thing is we've done some trials using this handphone app, measuring chlorophyll concentrations in Sabah waters. And so far, we find that the this smartphone app could be used as a tool or sensor using to measure chlorophyll A in the field. So you just need to take a photo of the color of the surface water, and you get a relatively accurate estimation of chlorophyll A. So with advancement of technology, these kind of apps will be becoming more and more useful for monitoring efforts. Yeah. So in summary, PSP cases remain one of the most important issues to address. Increasing fish kills incidences are affecting the aquaculture industry. What we have to do is to get all the relevant stakeholders, the fisheries department, biosecurity unit, aquaculture industry to work together to address HAV issues. And also monitoring is a very important thing in order to prevent or to have a rapid reaction for mitigation efforts before HAV becomes a problem. Lastly, I'd like to acknowledge the team from CHABS, Synoptic Environmental Alert System for Harmful Algal Blooms, and also my students, Brian, Santa, Chungo, and Chengi. And funding was obtained from FRGS, National University of Singapore, and other authorities. Okay, thank you very much.
Thank you, Dr. Teru. Very interesting sharing. And I'm from Kota Kinabalu, and growing up, HAB is always, my mom will be worried so much whenever there's algae bloom, poison algae bloom. So I think the audience, they are very concerned about HAB as well. And I think we have few questions for you, Dr. Teru. So the first one from Lei, thank you so much for the question. Same species of phytoplankton causing HABs all over the world? Is that the case?
Yes, yes, because these many HAB species can be found in tropical as well as temperate waters. For example, Coclodinium is relatively, the range of distribution is relatively narrow, ranging from tropical to subtropical. But for other species like Pyrodinium, is very common to be found in temperate waters as well. So the same species. You have to remember that the HAB species, those that are toxic and harmful, are very limited. I think basically phytoplankton are very good for the environment, because if you have an increase of phytoplankton, you get more food sources for the zooplankton, and it keeps the productivity of the ocean healthy. But these certain species, only the limited number of species, cause actual negative effects.
Okay, thank you, Dr. Teru. Another questions from Michael Tan. I think Michael Tan is I think he really enjoyed our program, because I remember he was here as well yesterday. Thank you, Michael Tan. So the question will be, could the lower amounts of PSP in 1970s be due to lower awareness, reporting rates, preserve records compared to 2010? So what do you think about this?
Yes, very good question. But the thing is, of course, there is a certain element, truth in that, because of monitoring, increasing awareness, we increase the efforts in monitoring. So therefore, we get to detect more harmful algal bloom events that were previously undetected. Yes, that is true. But the thing is, if you look at studies where they have a fixed station and they sample, they monitor the presence of HAB species, you get to see that at the same area, there's an increase in the occurrence of HAB species. So yeah, there's some there is concrete evidence that there is increasing frequency and also extent of HAB events throughout the world.
Okay, thank you, Dr. Teru. I think we can take another questions. Another question for Dr. Teru. Is there any? Yes, from Lei again. In Southeast Asia, which country is severely affected by HAB and why?
Southeast Asia is a developing area. So many developing countries are focusing mainly on economic growth. So you see that there is less focus on protecting or conserving the environment, and also less awareness in these environmental issues. And in general, I cannot say which countries, because Indonesia, Thailand, Philippines, they are all developing countries with the similar problems of economic growth affecting the environment, marine environment. So in general, because of increase in these economic activities along the coast, and also increase in population and increase in output of pollution into the ocean, you get to see the effect on the number of HAB blooms in the region. So I can say certain areas, like if you are to specify which areas that are affected, like Gulf of Thailand, Manila Bay in Philippines, and then Indonesia is generally throughout the coastal waters of Indonesia, because aquaculture is a booming industry in Indonesia. So you get the effect of these polluted waters into the coastal areas. So I think in general, overall, throughout Southeast Asia, we are facing the same problem. And because the sea is connected, we form these research groups or research collaborative efforts, country to country, to tackle this issue of HABs.
Okay, thank you, Dr. Teru, for that very detailed explanation. And at least I'm not really worried now, because only few species of phytoplankton that cause this HAB. So next, thank you, Dr. Teru. So next, we will go to the next presenter. We will have Puan Wahidatu. Her expertise is on aquaculture, especially on seaweed culture. She has been with the Institute for 8 years now. And today her presentation will be on sea vegetables, sea to the kitchen journey. Very interesting title. Okay, the floor is yours, Wahi.
Thank you, Dr. Juanita, for the very lovely introduction. So everyone, hello everyone. I'm Wahida, and I'm actually working on seaweed culture, or atau orang Sabah bilang rumpai laut bah, lato kan. So first of all, I hope everyone is safe and sound during this outbreak COVID-19. Yalah, time-time macam ni kan is one of the hardest moment for us, right? So today I will just share my experience working with seaweed, and I would like to invite everybody who is watching right now to value one of our marine organism, which is seaweed ataupun rumpai laut lah kan. Alright. So why I call seaweed as sea vegetables? Because if you see the structure ataupun the texture of seaweed itself, ada yang seakan-akan rupa brokoli, ada yang seakan-akan rupa sayur sawi, and some of the seaweed looks like even a spinach ataupun sayur bayam kan. So it's very interesting actually to study on this marine organism, yeah, especially the seaweed lah. So I would like to introduce our valuable marine organism, which is seaweed, right? So apakah itu rumpai laut? Apa ba itu rumpai laut kan? What is seaweed actually? Banyak, I think few years back, our government really stress on seaweed kan, especially when they put seaweed as one of the main item in the EPP3, di mana seaweed is one of the important thing dalam kita punya penjanaan ekonomi negara kan. Dan ada satu fasa, there's a phase bila mana orang sangat teruja dengan rumpai laut sehingga kan boleh dijual 1 kilo semahal RM200 ke atas di Semenanjung lah kan. Dan rumpai laut ni waktu itu saya ingat diorang kata ada collagen. But I just want to make it clear, collagen is the type of protein yang mana kita boleh jumpa di haiwan. Kalaupun di tumbuhan adalah di kekacang ataupun what we call as legumes. Dia tidak ada di tumbuhan. Tapi dalam rumpai laut, actually inside the seaweed, we have a biochemical compound or a component yang seakan-akan collagen sebab bentuknya yang gelling. Dia seakan-akan bentuk gel. So the component is we call phycocolloid, what is we call carrageenan ataupun gel lah, ataupun agar. Okay, so we have to make it clear lah, takut nanti ada orang overclaim kan. Right. So yeah, let me introduce you what is seaweed kan. Seaweed is actually a type of marine. Marine maksudnya di lautan lah. Marine macroalgae. Dia adalah sejenis algae. It's a type of algae that looks like plant. It's not a real plant like terrestrial plant, but it looks like plant. Because why is it different? Maybe because of the morphology and in terms of the phylogenetic. Okay, so seaweed ni we have three main types of seaweed lah, which is actually classified atau differentiated in terms of the thallus color, right? Ada yang we call it red seaweed, but it is not necessarily red. When we call it red seaweed, it can be green as well. When you see the picture, it's actually a type of red seaweed ataupun alga merah, macroalga merah, but it's green in color, which is so interesting to study actually. And then we have brown macroalgae ataupun seaweed, orang kata seaweed coklat atau seaweed perang lah, brown seaweed, and we have green seaweed. Okay, di Malaysia ini kalau kita jalan-jalan dekat pantai, especially kalau di perairan Sabah ni, when you walk along the beach kan, the coastal area, you will see macam banyak pokok-pokok kecil yang terampai di tepi laut tu kan. That's actually a type of brown seaweed. We call it sargassum. It's a type of brown seaweed lah. Alright. Okay, so we have to remember rumpai laut ni dia ada 3 jenis yang utama, which is brown, red and green ya. For those yang baru mau mengenali rumpai laut ni lah. Okay. Alright. Next. Okay. Yeah, okay. Yeah, I just want to share, dekat Malaysia ni, we are not culturing a lot of different type of seaweed lah. Okay? Our focus is more on red seaweed. Why? Sebab di Malaysia, red seaweed ni adalah something yang very beneficial because of the component di dalam red seaweed itu. So dekat Malaysia, kebanyakan kita culture adalah what we call Carpophycus and Eucuma species. So yang dalam gambar tadi yang warna hijau tu is actually Carpophycus seaweed lah, right? So Carpophycus and Eucuma ni dalam banyak-banyak negara yang involved in seaweed industry, they will culture this species because of the carrageenan content. So what is carrageenan actually? Later on I will show you what is carrageenan ya. So this is the types of seaweed yang kita biasa dengar latok di Sabah ni is actually a caulopa seaweed. What we call as Caulopa lentilifera dalam bahasa saintifiknya lah. Okay, and then we have a type of red seaweed and brown seaweed lah. Kalau di luar negara, jangan terkejut. Actually, di Eropah juga ada rumpai laut. What we call as brown seaweed, kalau tengok rumpai laut mereka besar-besar. Kan, mereka ada types of laminaria and saccharina. Okay, yeah. So, jangan terkejut. Seaweed is worldwide. Okay, rumpai laut ini kita boleh dapati di mana-mana. Selagi ada laut, di situ ada rumpainya. Alright, so I want to stress mostly cultured in Malaysia adalah Carpophycus and Eucuma. So this is a brief introduction di mana seaweed ni sebenarnya boleh dikatakan some sort of superfood. Actually, government of Malaysia in 2018 they requested from the UN to acknowledge our seaweed as one of the superfood. Kenapa superfood? When we talk about superfood, it's actually dia boleh reflect as food yang ada banyak nutrient. Sebab rumpai laut they actually contain polysaccharide ataupun what we call carbohydrate. Mereka juga ada a lot of minerals and vitamins. Seaweed juga ada a little amount of lipid and as well as fiber, dietary fiber. So that's why government of Malaysia, they are thinking of acknowledging our seaweed as part of superfood. They propose to United Nations to acknowledge our seaweed as part of superfood. And even the United Nations actually, they projected that the population in the world will increase years by years, right? So we are gonna face a shortage of food and job or living sources, right? That's why if we open up another opportunity, which is seaweed industry, which will help to not really truly solve the issue, but maybe reduce the problems that we will face in the future, right? Okay, so seaweed is also acknowledged as one of the largest aquaculture crop instead of fish and mollusk. We know, kita tahu dalam industri aquaculture ikan antara hidupan yang banyak dijual dibeli, termasuklah udang, kerang dan juga ketam dan sebagainya. Tapi kita tertinggal bahawa rumpai laut juga adalah antara marine organism yang banyak dijual dan dibeli dalam industri aquaculture. Tapi di Malaysia is not as wide as what people in Indonesia and China and Philippines, di mana industri rumpai laut mereka lebih berkembang berbanding di Malaysia. Right, this is just to show you how the seaweed industry is really important for us actually. Not only for Malaysia but for the whole world. It's a global demand actually. Alright. So when you talk about global demand, actually there's a prediction in 2020, now it's 2020 actually, the global demand of seaweed will increase from 23% up to more than 50%. But when we see now, 2020, the seaweed industry in Malaysia is still developing, right? But we have a lot of seaweed resources and we need a lot of experts. We need a lot of people who will be interested in seaweed, and we need everyone to get together and bring up the industry to the worldwide. Alright, so this is just a figure of the global demand that is being projected by the World Bank, not only by Malaysian government, but by the World Bank. Alright, so yeah, can I have the next slide, please? Santai-santai saja kan? Alright, this is one of the statistical data on how many countries involved in seaweed cultivation ataupun pengkulturan rumpai laut. Malaysia is part of it, so we are not left out actually. We are actually really active in developing the seaweed industry. So next one. Yeah, this is the type of seaweed ataupun jenis rumpai laut yang kita culture and the rest of the world culture. As I said, even in the Western countries, European countries also involved in seaweed cultivation. Not only the Asian countries, but also the European countries, the Western people, they also consume seaweed. Alright. So yeah. So this is one of the example di mana ada juga negara lain yang terlibat dalam pengkulturan rumpai laut, dan this is actually the types of seaweed that are being cultured. So next one. This is just to show you the picture. This is actually the types of seaweed available inside our ocean. In conjunction with the World Ocean Day, I would like to invite everyone to value this marine organism. Okay, this is the example of seaweed that existed inside our ocean. Alright, next one. I will show you the pictures actually, interesting pictures. So that's the one that I showed, that I told you before, Carpophycus, Gracilaria is actually, if you remember, one time dulu kita ada agar-agar yang macam bihun tu kan, it's actually a processed seaweed di mana mereka keringkan dan bolehlah jadi agar-agar, bolehlah masak-masak di dapur kan. Alright, next one. There's more pictures coming in. This is examples. Porphyra. Porphyra is actually, siapa yang suka makan sushi, yang itu macam daun-daun yang dibikin wrap itu sushi is actually part of Porphyra. It's actually Porphyra seaweed. Orang Jepun panggil nori. Okay, Saccharina laminara is popular in Western countries in Europe. And this is the green algae, kolopa ataupun orang Sabah bilang latok, yang sekarang I think viral dekat YouTube. Orang buat what we call it, makan latok lah, which is good actually because they promote one of our rumpai laut. Alright, next one. Okay, yeah, this is actually the countries yang involved dalam seaweed production. So if you can see, kalau tengok dalam world map itu, we can see Malaysia. So we should be proud with our country sebab kita pun boleh the same level with other countries yang involved dalam seaweed production. Because seaweed is very valuable. Later on, I will show you the value of seaweed itself. Okay, so next one. Alright, this is just to show you, to prove to you that actually not only Malaysia or Asian country yang terlibat dengan rumpai laut. Okay, we have China, we have Indonesia, we have Philippines. Right, next one. Even in in Brazil, okay, people are culturing seaweed. In Europe, Canada, Portugal, South Africa, I think the whole world is actually working on seaweed. But in terms of the massiveness or the abundance is different. Alright, next one. Okay, like I said, in Norway, even in Japan, Japan is the most active seaweed producers, even though they are not the highest producers. But Japanese people, they like to eat seaweed. That's why sushi came up. That's why we can eat sushi, and also Korean people, that's why we have kimbap. Alright, next one. Alright, yeah. Why do people culture and consume seaweed? Because of the benefits. This slide I will just go through laju-laju. Okay. Sebab seaweed ni, jangan terkejut seaweed is not only for fresh consumption, not only for salad. Seaweed juga kita boleh extract untuk buat pelbagai kosmetik. Dia ada compound yang kita boleh buat sebagai baja. Then we can use it as any kind of industrial application lah. Alright, in foods, in fertilizers, and if you know, okay, later on I will show you the picture of our santan, our famous kara santan yang sedap. They also contain one of the component from seaweed, what we call carrageenan. Okay, next one. Alright. Yeah, this is just a brief idea macam mana orang proses seaweed. One of the the main three process will be extraction. Mereka extract any component from the seaweed, and they produce any kind of end product. And then ada fermentation, and then ada pyrolysis, and these are actually the examples of products yang kita boleh buat daripada seaweed ni sendiri. Okay, next one. Laju saja. Okay, jadi kita terfikir seaweed ataupun rumpai laut yang banyak ampai-ampai di tepi pantai itu kan ada benefit ke tidak? Adakah dia mengandungi nutrien sama seperti sayur? Kan? Is it comparable with sea vegetables? Okay, move on to the next slide. Okay. Mereka sebenarnya seaweed ni contain polysaccharide ataupun what we call carbohydrate, type of carbohydrate. And majority component dalam seaweed ni adalah polysaccharide. Dan carrageenan yang saya sebut-sebut tadi tu adalah a type of polysaccharide as well. So carrageenan ni is actually, kalau orang yang suka healthy diet, mereka akan ambil carrageenan sebab dia adalah natural gelling agent and binding agent, di mana orang akan extract daripada seaweed dan letak dalam any kind of products. Daily products yang kita consume like chocolate, susu, santan, our coconut gravy kan, and jelly, a lot of things yang kita guna setiap hari. Even biscuits pun ada yang menggunakan carrageenan sebagai binding agent. Okay, laju-laju. And then seaweed also contain dietary fibers. Jadi siapa yang mau diet tu, makanlah seaweed sikit-sikit, senanglah mau menguruskan badan kan. Okay, next one. Okay, ada proteins. Seaweed juga ada certain seaweed, contoh macam seaweed hijau, kolepa, mereka ada protein yang tinggi. Around 20 to 21% is the normal range of protein content di dalam kolepa hijau, di dalam rumpai laut hijau. Mereka juga ada certain amino acid. Amino acid ni adalah komponen makanan ataupun nutrien yang kita perlukan. Alright, next one. Ada juga lipid. Lipid ni lemak tapi bukanlah lemak yang tinggi. Mereka ada around 1 ke 3% saja lipid. Lipid ni adalah crude lemak, crude lipid. Alright, next one. Dia ada vitamins, dia ada minerals. Okay, a lot of vitamins and minerals. Laju. Okay, dalam seaweed juga, that's why we can see a lot of different varieties of colours of rumpai laut kan. Because mereka ada photosynthetic pigments. That's why I call seaweed as sea vegetables. Mereka juga seakan-akan tumbuhan. Mereka mendapatkan tenaga untuk membesar melalui proses fotosintesis seperti mana tumbuhan. Dan dalam rumpai laut sebenarnya ada beberapa pigment. Pigment ni yang boleh menyebabkan coloration. Mereka ada chlorophyll yang buatkan dia colour hijau, carotenoids dan phycobiliproteins. Carotenoids kalau nampak dalam warna orange, warna merah, reddish orange tu, mereka ada certain pigments. Alright, next one. Okay, these are the types of pigments. Saya rasa saya tak perlu ulas. Okay, this is the example, macam contoh, this is brown seaweed. Mereka ada certain pigments yang boleh menyebabkan coloration of the seaweed. Okay, next one. just pictures. I just want to show you the pictures of our beautiful seaweed. Next one. Right, this is our green seaweed. Green seaweed sangat cantik, macam sayur. Okay, next one. This is Kappa ficus yang banyak kita culture dekat Malaysia, not only di Sabah. Sabah is the highest state producing this Kappa ficus. We also started to culture this Kappa ficus di Langkawi, Pulau Pinang, as well as in Pantai Timur Malaysia, Kelantan and Terengganu. Even di Kelantan, Terengganu pun ada seaweed yang tersendiri. Yang mana orang Kelantan kalau familiar dengan nama kerabu sare tu, itu adalah a type of seaweed as well. Okay, this is just a further explanation on chlorophyll yang terkandung dalam rumpai laut. Dalam rumpai laut juga kita ada metabolites yang lain yang penting untuk kita consume. Alright, next one. Okay, carotenoids. Okay, next one. This is just a brief explanation. Seaweed juga terkenal sebagai antioksidan. Kalau kita tahu buah-buahan adalah antara makanan yang banyak provide antioksidan, seaweed juga ada antioksidan. Macam kita tahu apple hijau banyak antioksidan, seaweed juga ada antioksidan. Okay. Betul atau tidak, UMS sebenarnya terlibat dalam research melibatkan seaweed, adakah dia mengandungi antioksidan property ataupun tidak. So kebanyakan penyelidikan yang dibuat menunjukkan result ataupun keputusan yang positif. Nampak tak nampak berharganya rumpai laut ini? Okay. Alright. So ini yang paling penting. My topic today mengatakan seaweed punya journey daripada laut ke dapur atau kitchen. So seaweed sebenarnya kebanyakan yang dikonsum adalah sebagai food product. Okay. Next one. Sebagai contoh ini, kalau di Sabah ni famous ni, dapat lagi dengan limau, dengan asam kan. Ini antara contoh macam mana orang makan seaweed. This is actually a Kappa ficus seaweed. Mereka buat fresh salad, right? This is one consumed by the locals, especially di Semporna. Even di KK pun orang akan consume this kind of salad. Alright, next one. This is for example, the example of Colopa lentilifera. Kita panggil latuk juga di Sabah ni, apa saja rumpai pun rasanya kebanyakan dipanggil latuk. Alright, next one. Okay, this is a very interesting part. Kita jumpa in our institute, we are involved with seaweed culture as well as finding interesting species tau. So recently we found not a new species, it's actually a very rare species. Kita jumpa di perairan Sabah, and this species is actually being consumed by the local people around Kuala Penyu and Menumbuk, and it's actually being sold. Dia dijual dengan harga RM20 sekilo, boleh mencecah RM20 sekilo yang fresh. This is Colopa macrodiscan. So anyone yang interested boleh datang ke Menumbuk dan try sejenis rumpai laut ni lah. This is the example of nori seaweed yang mana di-serve dekat one of the restaurant in Japan. Okay, next one. Okay, this is also, ini bukan di Asia. One of the hotel in Big Island, they actually serve pickle seaweed salad. Okay, dia seaweed yang dijeruk, rumpai laut yang dijeruk. Okay, next one. Okay, this is the example of seaweed pasta. Okay, rumpai laut juga boleh dibuat sebagai pasta. Kalau di Malaysia kita buat mi, kita buat mihun. Di luar negara mereka buat pasta. This is what I told you before. Our santan, the famous kara santan yang mak-mak suka guna ni, yang ibu-ibu guna, they also contain carrageenan, part of the component from rumpai laut. Okay, next one. Next one. This is the example of carrageenan contained in milk. Right, next one. Okay, this is the example in Japan. Ada satu company. This company produce several lines of seaweed products. Next one, I'll show you the products. They sell the seaweed salad on the go. Macam Maggi and bubur yang instant tu, but this one is seaweed salad. You can just grab it on the go and then just makan dalam kereta ke, dalam train ke, kan, just grab on the go. Very easy, right? Okay, next one. So this is the example of seaweed chips. Ada orang dia suka makan kerepek rumpai laut. Sedap kan? Begini rasa dia. Okay, next one. This is the example. Even di Sabah atau di Malaysia sendiri pun ramai sudah orang start menyukai atau menggemari kerepek rumpai laut. Okay, next one. Okay, ini pula di belah western countries, di Europe. Di Europe kebanyakan mereka mengculture ataupun mereka cultivate sejenis rumpai laut dipanggil kelp. Kelp ni adalah rumpai laut brown seaweed yang besar-besar. Okay, next one, you can see the picture. Maka di mana mereka produce seasoning, rempah ratus daripada seaweed. Yang uniknya seaweed ni, dia mengandungi sejenis garam yang bagus untuk jantung. We call it potassium lah, okay, potassium chloride. That's why people will use it as seasoning. Satu, dia memang dah rasa masin. Yang kedua, dia ada health benefit. So this is the example of seaweed drinks. Okay, next one. Bagi yang menyukai produk kosmetik, produk kosmetik dan produk penjagaan tubuh badan dan sebagainya, even produk yang famous, Lush product juga menggunakan one of the component from rumpai laut, seaweed. Okay, next one. Yeah, I think that's it. That's all about seaweed that I want to share with all of you. So I wish everyone would at least have the interest to further explore the value of our marine organism, seaweed. Yeah? Okay, thank you everyone for listening. I think that's it. Pass over to you, Dr. Juanita.
Thank you, Wahi. Very interesting. Especially yang saya dengar tu pasal untuk diet, low cholesterol level, itu yang baik tu. And for your information, my favorite is Big Bang. I'm not sure whether that's healthy, Big Bang. So I've been having that in my office. So menarik tentang seaweed ni. Banyak kegunaan. And I think we have one question or two questions for you, Wahi. So, okay. So the question from Nabila, thank you Nabila for the questions. So what is the future of seaweed culture in Sabah? And also she asked, what is your comment about sea turtles that kept on disturbing the seaweed culture in Semporna? Ini yang pasal mungkin seaweed culture dekat Semporna, sometimes they will hit the turtle because the turtle come and eat all the seaweed. Okay.
All right.
Okay, well, yeah.
Yeah. Regarding this question, kan, it's actually a very interesting question. Thank you, Nabila. So I really have a big hope with the seaweed industry in Sabah. Okay, I have a big hope, even though during this pandemic COVID-19, I know the seaweed industry will grow, will bulk up and grow and develop again. So I think if we really focus on developing this industry, the industry will grow better and much bigger. Even though we can see Sabah sendiri, the government of Sabah, they have put seaweed as one of the Sabah agriculture blueprint for 2021 up until 2030. So if anyone interested with seaweed culture, we can actually discuss and we can work together to develop this industry itself. So even in the national level, the government actually also focus on seaweed as part of the agriculture blueprint. So there is a hope. There's a big hope for there's a big hope and there's a big future for the seaweed culture in Sabah. Not only in Sabah, in Malaysia. I think a lot of the states in Semenanjung as well, they started to explore the seaweed culture in their state. For example, in Penang and also in Langkawi and even Terengganu and Kelantan. They started to further develop the seaweed industry in their state lah. So my comment on the sea turtle, okay, sea turtle ini kalau dia nampak rumput laut, dia rasa macam kenduri lah. Kan? Actually, we can overcome. My experience working with seaweed culture kan di Semporna, bila kita sudah tanam banyak rumpai laut, dia macam orang jugalah pandai jemu sudah. Kan? Bila terlalu banyak dalam satu kawasan, they actually will bite like just a bit portion of the seaweed. Sebab terlalu banyak, dia pun tidak sempat sudah mau makan itu seaweed kan. But for me, we can overcome these grazes lah. This threat by this sea turtle, I don't think it's a big deal lah for the seaweed industry. We can still overcome the issue on sea turtles and engulfing the seaweed kan. Our main concern is actually how to develop the industry and how to get manpower lah sebenarnya. Alright. Okay. I believe there's another question.
Yeah. Ada, tapi kita teruskan dulu kepada panel seterusnya and then kita akan tanya soalan selepas ini lagi. Okay, thank you Puan Wahi, very interesting talk.
Okay, right.
So next, I would like to call Dr. Madiha Jafar Siddiq. She's a senior lecturer at the Institute and she was with IPMB since 2008 and she has a PhD from Bangor University North Wales, United Kingdom, in the field of oceanography, and Dr. Madiha is specializing in the area of ocean color, remote sensing, and marine optics. Very interesting. Okay, I would like to invite Dr. Madiha. Thank you.
Thank you, Dr. Juan, for the introduction. Okay. Today, I think it's not too late to say Happy Ocean Day and Happy Coral Triangle Days. Yeah. Okay. This afternoon, in Ocean Talk slot, I would like to share my perspective on ocean color in coastal water. Yeah. Can we go to next slide, please? Okay. Ocean color is one of the physical oceanography branch. Yeah, it's relates or it involves with physical processes in the ocean, and also it's contain physics theories, law in the ocean. Yeah, before I start more technical, I would like you to think, what is the color of the ocean? Yeah, for example, in our area in Sepanggar Bay, warna-warna air laut. Is it similar like Atlantic Ocean? Yeah, blue color, or is it turquoise color, like North Sea? Or maybe we can see in the river, sometimes it look like milky tea, after raining season, it's like Milo ice, or maybe it's coffee. Yeah. So what do you think? Is it why this color keep on changing? Is it you need to let's imagine. Is it any changes within hours or within days, months, or years? Okay. So to answer this question, I would like this is the answer why the color looks a certain specific color. Okay, the color of the ocean is determined by the interaction of indecent light with the substance or particle present in the water. Means that warna air laut tu disebabkan dia interaction with the particle, suspended particle in the ocean. So the substance, which is a react, or in this case, they react like absorbing or scattered the light. So the particle that experiencing ataupun dia able to be absorbed or scattered by the light, we known as a color producing agent, or in short we call CPAs, which is SPM, short form for suspended particulate matter, chlorophyll. Earlier panel, Dr. Teruaki already mentioned about the chlorophyll in the ocean, how it varies. Sometimes we got red tides, sometimes not. Because it also react with the light. And also sedum. Sedum is colored dissolved organic matter, which is come from the river runoff, kesan daripada daratan. Okay, so these three things, CPA, we can classified or generally referred as a water quality parameter. Sometimes we check the quality of the water. It's also rely on the CPA. And how the CPA react? Because it react with the light. Okay, as we know that light come from sun. Okay, so when it strike to the ocean, so it will the particle inside the ocean will absorb and also scatter. When it's scattered, that's why you can see the light. Okay, if you see the slide, there's orang lidi, tadi tu. The color, okay, for example, sunlight, bila dia strike to the particle, suspended particle in the ocean, so it will scatter blue. So means that we can see the color of ocean blue. For example, if the color of the ocean red, for example, means that they absorb other visible light, which is the rainbow, the RGB, red, green, blue, and it scattered the red color. So we're playing with the absorbance and also scattering of the particle or constituents inside the ocean. So you can see here the incident light, and not yet. Can you go to the next? Okay, means that the phytoplankton dissolve organic matter and also SPM also absorb and also scattered in the same time. Yeah, so it will give us the color. Okay, can we go to the next slide, please? So we talk about absorbing and also scattering. Yeah, this is about the optical properties of the particle. Yeah, it's quite easy. I'm sorry to give you in the afternoon with the equation. Yeah, it's a bit nampak complicated. It's a bit complicated, but don't worry. If once you understand, you might enjoy it. Yeah, you see like the very interesting part. Okay, yeah, if you see that C equal A plus B, yeah, A seems the absorption coefficient by the phytoplankton or by sedum and also by the suspended particulate, and B is scattering, which is the color that we can see, which color it's wind in that water. Okay, so as we know that sunlight is electromagnetic radiation, which is between 400 and 700 nanometer wavelength. So it will compete which wavelength will win. Yeah, so it means that when you see the ocean after this, you may, oh, okay, I see blue. Oh, means that the scattering of blue color or blue wavelength, short wavelength, which is 400, strike to your eyes. Okay, our eyes is very special from God, a gift from God. We also have a receptor is RGB. It's like similar dia punya application like a satellite. Yeah, satellite learn from human beings. Yeah, so maksudnya we can see RGB in our eyes. Okay, can we go to the next slide, please? Okay, so we already know what is color producing agent, CPA, and we also know what is optical properties. It's about the absorbent and also scattering things. Yeah, sunlight towards strike to the particle inside the water. So we can classify ocean or natural waters into two groups. Yeah, in remote sensing. Yeah, because why we need to classify it? Yeah, because every CPA components react differently. Yeah, it has their own characteristic in optical properties. Yeah, for example, water molecule will absorb all the colors, only the blue color that it will scatter, and it also same to phytoplankton. It's differently. So that's why in satellite or in marine optic or remote sensing studies, yeah, we need to know what is the type of our interest interest water lah, study site. Either it's case 1 waters or it's case 2 waters. Yeah, so here I already mentioned, I already put tabulate what is the case 1 water, which is optical properties dominated by phytoplankton and also sedum. Yeah, only 2 things. It's very, in remote sensing, it's quite relatively easy to monitor ataupun to observe case 2 water. Case 1 water, open sea, because it only contain 2 CPS, color producing agent, constituent yang react with the light. Okay, and then case 2 water is optical properties are significantly influenced by mineral suspended, sedum and phytoplankton. So you can see a triangle diagram at the down at of the table. You can see case 2. We need to take into account these 3 things, how it react. Okay, which one will win? Yeah, and then case 2, it's quite easily, relatively easily. Yeah, so only 2 things. Yeah, only 2 that optical parameter yang kita boleh tengok. Okay, can we go to next slide, please? Okay, so would you imagine the complexity of optical properties in coastal water? Yeah, as previous panel just now, Puan Wahida has mentioned about seaweed in coastal areas. So that's why in oceanography we are the supporting teams that to monitor, is it suitable for aquaculture, it's suitable for seagrass culture or coral reef ecosystem. Yeah, how this color, okay, how the CPA react in this particularly marine ecosystem. Yeah, each ecosystem, it has their own optical signature. I think I catch one that words in Dr. Terwaki's slide just now. Yeah, if you still remember. So they means that different ecosystem, it has different CPA signature, or we can say that optical signature. Okay, in my interest of research, I would like, yeah, I love to study coastal area because coastal area is very productive area. It's very useful to humans or social economic. But how these components, yeah, we can monitor. Yeah, is it, can we monitor from the sky using satellite? Yeah, how it, so we cannot stay on that place. Yeah, for example, we want to culture seaweed and then we want to check the water quality. Yeah, it will consume time. Yeah, so we need to try to get very easy way to monitor and observe the suitable, is it any change, the changes, yeah, for the changes of the water quality. Okay, can we go to next slide, please? Okay, yeah, color of coastal water. This is, I already mentioned just now. It's governed by the CPA concentration, yeah, SPM, chlorophyll, colored dissolved oxygen. Yeah, and then as we know that Malaysian, we experiencing monsoonal season, yeah, during monsoon, inter monsoon, so it will change, yeah, it will affect the suspended. Okay, the wind direction change means that the current direction also change and might be affected. Yeah, it's dominantly affected the suspended in suspended CPS in that certain ecosystem. Okay, so we have seagrass, aquaculture, coral reef, estuarine, and mangrove. Yeah, I think we already discussed about coral reef yesterday with Dr. Zarina. And okay, can we go to the next slide? Okay, how we measure the color of the ocean? Okay, basically we can classify into two types of method. Yeah, first one is human eyes. Yeah, as I mentioned you earlier, God give us very precious gift. Yeah, which is our eyes. We can see visible light, which is 400 nanometer to 700 nanometer. Yeah, when the light strike, for example, strike to your shirt, and then which color scattered and strike to your eyes, this is the color that your brain will processes. Oh, okay, means that the color is blue because blue scattered towards your eyes. Yeah, and then it's similar with the ocean color satellite. Okay, we have when sun strike to penetrate to ocean surface, and it will reflect back. Okay, this it's involved. It's not easily. There's involved a lot of equation, but this is only the diagram how you to make you understand lah how it react. Yeah, and then it will scatter which color, and then your the satellite will detect which color will be scattered by the ocean. So in this case means that the particles CPS is the one is the things that play the role important to make the color of the natural waters. Okay, can we go to next slide, please? Okay, yeah, how to measure ocean color? There's a two way how we measure it. Okay, one is a Forel-Uhl comparator color scale, which is a historical. Okay, this color classification has been used since 19th century. Okay, it's introduced by Francois Alphonse Forel and also Willy Uhl. Okay, if you see at the at the top of the slide, you can see number 1 until number 2 color scale. Yeah, this is the color scale of Forel Uhl. Yeah, we can so you can see how the researcher measured the ocean using the Forel Uhl scale. Yeah, using the Secchi depth, and then lowered the Secchi depth first, and then make it half of the Secchi depth, and then they will match color of the water Forel Uhl scale with the color above the Secchi disc. Okay, that is historical and still valid until now. Yeah, in Europe, they're using this instrument. I can say the instrument very simple. It looks like, yeah, everybody can use it as a for citizen science campaign. Yeah, so it means that not only scientists can classify ocean color, everybody can classify ocean color if you have eyes. Yeah, because our satellite also react like our eyes. Okay, so ocean color satellite, this is a very famous research. Okay, it's started since 1975 until now. Yeah, there's a different satellite. Okay, so I would like to share why I love to do research in coastal water. Yeah, not only because coastal water, as I mentioned before, it's very productive, it's very important area, because of we are in the equator, which is we are having a higher evaporation process. So if evaporation process means that you will create the cloud. We can see cloud every day, yeah, in our sky. So it will hinder the process of satellite observing. Yeah, like satellite cannot retrieve ocean if there's a cloud cover. It will be noise. Yeah, so that's why we need to complementary these two equipment. Yeah, means that historical, which is very robust, we still can use it. Yeah, to classify the water, ocean, the color of the water, and also the satellite. So it's complementary. We cannot rely on satellite. Okay, and then another problem, yeah, in equator, satellite not pass every day like in the temperate or polar, because of our the shape of our Earth itself. Yeah, because it have a big diameter in equator, so the satellite pass, it will take 2 weeks to get to the track, in the same track. So that's why it's very difficult to get ocean color observation derived from the satellite. Okay, can we go to the next slide? Okay, previous work. Yeah, previous ocean color study. I did my PhD in Bengal University for optical measurement of suspended sediment. Yeah, I can say that it's still new in this. I'm still a lot of more to learn about the optical. Yeah, I published 2 papers. So it's about optical properties, about ocean color, marine optic studies in the European waters. Okay, so I'm back here. This is time for me to serve the country. So can we go to the next slide? So this is ocean color and marine optic studies in coastal water in Sabah. Yeah, so now I am progressing, have a kickstart to do more research in optical study or ocean color and remote sensing studies in Sabah waters. As you know, I think everybody knows Sabah is very good in seafood, so that's why we need to monitor. It's very important to monitor the quality of the ocean, so we cannot. Yeah, sometimes if we go by boat, it will consume very expensive cost. So in that time, we need satellite. But satellite also, we have also a problem, yeah, because of our location. So we need these two methods complementary each other. Okay, so these three posters done by my postgraduate student, yeah, currently. Okay, can we go to the next slide, please? Yeah, this is a list of research grants. So I have currently I have 5 research grant. I have I have a grant with as a member, yeah. But this 5 grant is very it's more related. I can say that it's generally study about marine optics. So to start this research in Sabah or in BMRI, I'm started with my undergraduate students, yeah, for FYP, yeah, to check the CPS thing. Yeah, we start slowly. Okay, and also I have 2 amazing postgraduate students, very hardworking. So they are helping me. We are work together to develop this group. Yeah. Okay, can we go to the next slide, please? Okay, collaboration. Currently, I only have 2 collaboration. Yeah, I'm looking forward to work with more agencies, university, because as you know that oceanography, primary remote sensing branch, ocean color, we need more people to work together. Yeah. So in this institute also, I also work very closely with Dr. Teruaki about the chlorophyll, and also Dr. Zarina coral reef. Yeah, how the CPS change, and the current study I work with Dr. Tamrin. So how the CPS satellite algorithm can react with the bacteria in the ocean. Okay, the last slide. Okay, if you're interested in ocean study, ocean color studies in UMS, yeah, you are welcome to. Please do contact me. Yeah, so we can exploring this very interesting study together. Yeah, more things to learn. Yeah, it's more excited. Okay, interesting field for me. Yeah, I came to teach you, or we learn together new new study or new research in ocean color study, ocean color research in coastal water, primarily in Sabah waters. I think that's all from me, Dr. Joan. Thank you.
Thank you, Dr. Diha. Very interesting talk. And yeah, ocean colors, new research. For those interested to do this research, please, you can email Dr. Madiha. Yeah, it's raining now heavily. So hopefully our internet connection will be okay. Thank you, Dr. Diha. And I think we have one question here from Sajenu. Can we detect pollution using ocean color and marine optics?
Yeah, I can say that we can detect ocean color. We can detect pollution. Yeah, using ocean color remote sensing. I think in remote sensing, there's many studies have been done in to detect the pollution. Yeah, and also marine optics. When we talk about optics, means that we are talking about the optical properties. So for sure, it might be changed. Yeah, the color, for example, oil spill, it will affect how the particle react into the light. Yeah. So yes, we can detect pollution using these 2 studies, from these 2 studies.
Okay, thank you so much, Dr. Diha. Okay, next, I would like to call upon my other colleague. So next, we have Dr. Nur Fatiha Abdul Khalid. Dr. Nur Fatiha, she's actually new in the institute. She joined us in November 2018, and she obtained her PhD from Universiti Putra Malaysia, and her field of study is on fish breeding and culture. And currently she is actively working on the research related to seahorse culture, seahorse aquaculture. And her presentation today will be on seahorse, aquaculture and challenges. Okay, Dr. Teha.
Hi everyone, thank you very much Dr. Juanita for the brief introduction. And Assalamualaikum, very good afternoon everyone. Happy World Ocean Day and also happy Coral Triangle Day to everyone. Okay, so as for today, I just would like to share some information regarding seahorse, specifically on aquaculture and what is or are the challenge of seahorse aquaculture activity. So let me share my slide first. Okay, so I will start my sharing for today. So before we go in detail about seahorse, I would like to introduce some of special characteristic or uniqueness of seahorse. Seahorse is very unique in the morphologically because they has horse-like shape of their head. So it makes their so-called seahorse since they live in the sea. Another unique characteristic of seahorse is the seahorse don't have any teeth. Okay, they don't have mouth like other. They do have mouth, but the shape of their mouth is quite different from other fishes. Okay, other than they don't have any tooth, they also have tubular snouts. Okay, their mouth so-called snouts. Okay, so not like other fishes that swim horizontally, seahorse swim vertically with their upright posture. Okay, so
Dr. Teha, sorry, is your slide, I think your slide is not out yet.
Oh.
Yes, can you reshare again? Yeah, sorry for interrupting.
Thank you, Dr. Juan. Sorry.
Yes, your slide is on.
Is it clear now?
Yes, very clear. Okay, thank you.
Right. Thank you very much, Dr. Juanita. So I continue explaining the uniqueness of the seahorse. Other than that, seahorse just like one of the fish that very common in our aquarium industry, which is the what's so called ikan bandaraya or ikan cuci cermin. Okay, it is because seahorse don't have any scale. Okay, and the body made up of bony plate, and not like other fishes that have caudal fin. Seahorse has prehensile tail, which is this tail been used to avoid them drift away to another place. Okay, in the wild environment. So next, this is the very unique or very special characteristic of the seahorse. I do like this fact because based on this fact, I recognize seahorse is very gentleman since the male seahorse is the one that get pregnant. Okay, how this thing happen? This thing happen when the female seahorse transfer the eggs into the male brood pouch. Brood pouch is the place to incubate the egg. Okay, as we can see in this picture. Okay, in our right side is the male seahorse and the male symbol pointed to the brood pouch of the male seahorse. Okay, and after the female transferring the eggs into the male brood pouch, then the male brood pouch will fertilize internally the eggs, and then the male will incubate the eggs until the egg ready to release, and the newborn seahorse that been released by the father. Okay, just look like the roughly like the shape of the seahorse. Okay, so we move to the next slide. Okay, in this slide I explain a little bit on the life cycle of the seahorse, how the seahorse reproduce and how they develop. Okay, so as we can see at the upper side of this slide, just now appear the embryonic development ataupun perkembangan telur pengembangan telur di dalam kantung seahorse tersebut. Okay, in this usually the duration of the embryonic development depends on the species of the seahorse. Roughly it take about 2 to 3 weeks, okay, to incubate the eggs inside their brood pouch, and then the newborn juvenile will release with, I explained just now, the shape just like the rough shape of the parents. Okay, then for almost all of the seahorse species in the world, okay, they will take about 7 to 11 days to move from the pelagic stage and until benthic stage. Okay, in the pelagic stage, basically the newborn seahorse just drift away in the water column. Okay, and this is the very critical stage of the seahorse during this pelagic stage. It's very fragile, easily affected by the changing in the environment. Mortality easily happen in this stage. Okay, so then after about 2 weeks, then only the seahorse, the juvenile seahorse, will settle at the bottom area. Okay, and then it go to the benthic stage. Okay, secara keseluruhannya seahorse akan melalui fasa di mana dia akan terapung, dia akan terampai di dalam air. Okay, pada fasa ini anak-anak seahorse sangat sensitif dan kematian senang untuk berlaku. Okay, dan after about 2 weeks only, anak-anak seahorse ni akan start memenuhi kawasan bottom, kawasan bawah, di bahagian bawah. Okay, bila once the seahorse reach the benthic stage, luckily they able to undergo the critical stage of the seahorse. Okay, so generally during the first 2 months of the growth, okay, seahorse undergo very slow growth rate. Okay, then after about 4 to 5 months old, we able to differentiate male and female seahorse using the secondary sexual dimorphism characteristic. Okay, secondary sexual dimorphism characteristic adalah karakteristik yang dapat dilihat dengan mata kasar. Okay, contohnya untuk membezakan jantan dan betina seahorse, jantan seahorse mempunyai kantung. Okay, yang mana kantung digunakan untuk mengincubatekan telur yang telah difertilizkan. Okay, so untuk most of the species is about seahorse take about 5 to 6 months, okay, to able from the date after birth, okay, untuk make sure it's able to reproduce again and again. Okay, so generally it's about 46 species of seahorse available in worldwide, but only 10 of seahorse species available in Malaysia. Okay, all 10 species available in Sabah, but only 6 species available in Semenanjung, Malaysia, and also only 6 species available in Sarawak. Okay, so as based on the record, okay, Sabah is very high in biodiversity. Okay, maybe because of that, all 10 species of seahorse that present in Malaysia can be found in Sabah. Okay, out of 10, these 3 species is so-called pygmy seahorse. What meaning by pygmy seahorse? Pygmy seahorse mean that the adult seahorse, the total length of adult seahorse just about 1 inch in total length. Okay, very small. Okay, very small. Just like the newborn juvenile of other seahorse species, the pygmy seahorse, even the adult stage is very small. Okay, so far I still unlucky. I didn't saw this pygmy seahorse by myself. Okay, so basically why we focus on seahorse? Why we want to do research on seahorse? Why people give attention on seahorse? Because seahorse has very great demand, whether live seahorse or dried seahorse. Both seahorse have very great demand in ornamental fish industry as well as traditional Chinese medicine. Okay, so this is how the dried seahorse been sold. I believe if people near the Kota Kinabalu, near the Pasar Philippine, we can see they sold the dried seahorse, okay, easily. But be careful. This is under extinction animals, so then it's been protected by the law. Okay, so next, this is how they use the dried seahorse, okay, for traditional Chinese medicine. And also this is how again they use the dried seahorse. They make keychain or for spiritual purpose, pendant, and also for souvenir. Okay. Okay, so this is how seahorse look like in the aquarium. So by the numbers, okay, yearly demand in seahorse is very high. For live seahorse, it's about 1 million pieces yearly, which is per piece cost about 1 to 80 USD. Okay, whereas for dried seahorse, the demand is about 36 million kilogram, which is per kilogram is about 800 pieces of seahorse. And how about the price? It's cost about USD 1,200 per kilogram. Okay, when I delivering this information, please, okay, don't harvest our wild seahorse. Okay, be careful. If you catch them, then later you been high potential to be cashed by the government. Okay, okay. This is since the previous slide mentioning about the price. So the price is estimated on 5 years ago. This is the current price. Okay, I just Google. This is the current price of the seahorse, quite high in price. Okay, so to prevent the over exploitation of seahorse in the wild population, the rules has been implemented. Okay, since we Malaysia one of the parties in the CITES, so we'll apply the law in our Act 686 is, if I'm not mistaken, in our Perlembagaan Malaysia. So be careful, don't simply harvest our seahorse in the wild, you will be catch. Okay, okay. So other than that, IUCN will also listed seahorse as a vulnerable species, and also the pygmy seahorse been listed as animals that will deficient in the data collection. Other than rule implementation, okay, to prevent this over exploitation of seahorse in the wild population, seahorse aquaculture have been introduced since 1990s. Okay, okay, this is some our seahorse aquaculture activity. We producing seahorse in captivity. Okay, so basically there are few universities, including UMS, being actively working on seahorse aquaculture. Okay, so this is the report, the place that conducted seahorse aquaculture activity worldwide. There are only 6 places actively conducted seahorse aquaculture activity, whereas there are no in Malaysia, even no in Southeast Asia. Okay, so basically each of these company have their own focus, whether to supply the demand or to educate the people or the communities about the importance of taking care of the seahorse. Okay, so basically seahorse research has been conducted, okay, to encounter the information data diffusion problem. Okay, so basically based on this figure or this slide, we can see that most of the research on seahorse been conducted on the species that present in temperate country. Okay, less research been conducted in species in our tropical country. Also more research been conducted on ecology part instead of aquaculture and biology. So more research need to be conducted to fulfill all the data diffusion information on the seahorse. Okay, so this is the generally give general information on the number of scientific publication on seahorse ranked by country. Sadly, there are no Malaysia recorded here. Maybe we have the number of publication on the seahorse, but maybe not significant compared to other country. So we need to work more harder, okay, in terms of research related to seahorse. Okay, so in this slide, I will discussing about how the seahorse aquaculture become very challenges. Okay, because of that, only limited number of company or activity on seahorse aquaculture being conducted. Okay, first of all is seahorse aquaculture is really depending on the live food. Okay, it makes seahorse aquaculture activity very difficult. Okay, many manpower required. Okay, when you maintaining the live food, okay, you cannot predict the future. Okay, is it the live food can be sustained or not? Okay, so more research need to be conducted on trying to replace the live food for the seahorse. Okay, other than that, there is another interesting information about seahorse. When the seahorse pair up, means the male and female starting to reproduce. Okay, they won't reproduce with other male or other female. They are very loyal each other. Okay, so once they start reproduce, they will keep on reproduce right after the male release the newborn. Okay, they won't stop. If you try to stop, based on my experience, if you try to stop them from reproduce, okay, they will having a problem, and they and potentially some of them die after that. Okay, so to ensure they have enough nutrient to produce good quality of the seed, the broodstock require nutritious diet as the broodstock require the nutritious diet. Okay, so other than that, culturing the newborn juvenile is quite is one of the bottleneck for the seahorse aquaculture. Okay, so we require very simple and efficient culture system, especially for the early stage of the seahorse. Other than that, yes, we have to maybe some research on control the disease affected the seahorse should be conducted. Okay, so last but not least, I would like to call anyone that interested in joining our team in BMRI to conduct a study on seahorse aquaculture. Please do contact me. Okay. So far, we managed to secure a few grants from Ministry of Higher Education. So we required more team members to work on seahorse. Okay, that's all from me, I think. Back to you, Dr. Juanita. Thank you very much.
Thank you so much, Dr. Nur Fatiha. And viewers out there, if you're interested to pursue your postgraduate studies, please contact Dr. Fatiha. And I actually, seahorse is always in my heart because last few years back, I was assisting a good friend of me, the late Mr. Chu Chi Kwang, who's been doing a lot of work in seahorse research in Malaysia. And for your information, Dr. Tiha, I've seen pygmy seahorse in Semporna.
Wow.
Yeah, so
I'm jealous of you.
yeah. Okay, I think we have question for you. It's from Nor Amalia. Salam, Dr. Fatiha. Thanks for the interesting sharing. Just want to know, up to today, is there any conservation effort for marine stock enhancement, restocking or sea ranching of seahorses being carried out in Malaysia waters or specifically for Sabah to replenish back our natural stocks?
Okay, thank you very much, Nur Amalia, for the question. Okay, basically, sadly to inform that they till today they are not yet stock enhancement program being conducted for seahorse. So we really hope that we able to capture all the constraint present in the seahorse aquaculture activity, and then we can produce a lot of seahorse to release back. Okay, to restock back them to our wild population. Okay, that is our team hope. Okay, I hope we can work to fulfill that that situation. Okay.
Yes, thank you, Dr. Teha. Very interesting talk.
Thank you.
So finally, we have the final speaker, my colleague, Dr. Nazia Abdul Qadar. So Dr. Nazia, she obtained her PhD in molecular biology in 2014. Then she joined UMS in 2016. Her research interest is on the population and conservation genetics of aquatic animals. And today, Dr. Nazia will share her research on freshwater fish diversity. Okay, Dr. Nazia.
Thanks very much, Dr. Juanita, for your introduction. Okay, Assalamualaikum and good afternoon, everyone. Today, I will share some of my preliminary results from our ongoing research at BMRI Universiti Malaysia Sabah. So next slide, please. Okay, so our first research is related with freshwater fish identification. So for this, we had chose Sungai Petagas as our research location. Sungai Petagas connects to the river. Sungai Petagas connects to the sea and upper river in Penampang is the main water supply and food source for the community living nearby. Okay, next. Okay, these are some of the pictures taken during our sampling. So, starting from the river estuary, the first picture, until along the river, there are some squatter area settlements along the river. Next slide, please. Okay, so our main objective for our research, our current research, is to produce checklist of freshwater fish species that is found from this river. So why is it important? Fish species diversity and composition are actually crucial to investigate the factors influencing the structure of fish community. Other than that, fish also can be used as a biological indicator for aquatic environment assessment to detect physical and chemical changes that alter the biological communities. So for this research, we use 3 different mesh size of fishing nets. So we use 1 inch, 1.5 inch, and also 2 inches size. Next slide, please. So once we have collect all the samples, we will bring all the fresh specimens back to the laboratory. Then we will identify all the specimens based on the morphological characteristics and also using taxonomic keys. Some of the samples will also be taken for phylogenetic analysis. Next. Okay, so this is the most dominant species, Aries maculatus, found in this river. This is the dominant species from the family Aridae. It has strong dorsal and also pectoral spines for protection. This fish basically feed on anything, and the main food is benthos and also detritus. So this catfish is known as hardy species because they can tolerate harsh environment. However, local people like to eat the eggs of the fish. Next slide. Okay, I'll just show some of the species found in this river. So other than that, we have ikan belukang, sago catfish, and also from other families. Next slide, please. Next slide. Okay, we even obtain puffer fish at the river. Okay, next slide, please. Okay, so basically we managed to collect about 474 fish, and out of that we successfully identified 16 fish species. And most of them, about 86%, are from ciliforms, followed by elopiforms and also mutualiforms, about 4%. And most of the species found is actually brackish water fish. Okay, next slide, please. Okay, so this, I would like to share this picture because when we went for sampling, what we can observe here is a lot of rubbish. Okay, so this river is heavily polluted mainly because of the direct garbage dumping directly into the river by the community living nearby, land-based runoff from the agriculture activities, and also domestic waste. So the amount of solid waste not only affect the aquatic organisms but also the village's health and also Sabah aesthetic value. So every time we went for sampling, our net will get entangled with the plastic waste that is floating on the river. So we had hard time to detangle back the net because we have to use the same net for the next station. We have about 5 sampling sites along the river. So our other objective is to create awareness on water pollutions with the community, with the local community, and for this, we are planning to give talks, especially to the school children. We're supposed to do it earlier this year, but we have to stop it because of the NCO, and we will resume back with the planning. Okay. Okay, so our research, the second research is focusing on Monopterus albus or Asian swamp eel. So these eels are native to Asian countries such as Malaysia, Vietnam, Cambodia, and Thailand, and it is economically important as local delicacies. So how do you differentiate between Monopterus albus and also other American eel like Angula or lamprey? So for Asian swamp eel, they don't have pectoral fins and their gill opening is in V-shaped. Their body also is olive to brownish color, and they usually prefer to their habitat preference is in stagnant waters, paddy fields or canals. They're hermaphrodite animals, which means they can change sex. So when they are born until they mature, they are female, but after they mature, they transform into males. Next. Okay, so swamp eel or eels, okay, they are also a famous food fish for local communities in Asian countries. Local people believe that eels has medicinal properties and they can used to be treat asthma, impotence, and also healing. And they are also high in protein, iron, and also calcium. Next, please. Next, please. Okay, so these are some of the sampling sites where we caught our eels. So these are the green color net and also the stick is used to catch the eels. This is traditional fish traps that we use during our samplings. So our main objective is to determine the length weight of the Monopterus albus and also to determine the genetic variation and population structure of the eels. So that's why at first when we collect the specimens, we will take all the measurements, the morphometric measurements, and also we will collect the tissue samples for DNA analysis for population studies. So the data is very valuable, especially if you want to establish proper monitoring and also management of this fish in wild and also in captivity. Among all the populations, Kota Belut, they have the highest average, which is the eel size, they reach until 90 cm. And for the weight is almost 470 gram in Kota Belut. And next slide, please. Okay, so this is the graph showing the length-weight relationship of swamp eels populations in Sabah. This is the combination for all the 5 populations. So basically all the populations, they have they have the negative allometric growth, which means the value B is smaller than 3. So it is definitely affected by factors such as food availability, environmental conditions, and age, and also other factors. Only one population showed isometric growth or positive allometric growth, showing B value more than 3. Okay, next slide. I think that's all from me to share for today. Thank you very much for listening.
Thank you so much, Dr. Nazia, for the interesting talk about fish diversity in Sabah. And I think we have one question. Yes, from Michael Tan again. So thank you so much, Michael Tan. The question is, will the people buying and eating fish from the polluted areas face any health issues?
Okay, thank you very much, Michael. I think if the people are not aware, I think they will definitely eat, right? Because
Yes.
we don't know, we don't know the originality of the food served. Yeah, that's all.
Yeah, okay. Thank you, Nazia. So we still have about 11 minutes to go. 11 minutes. Maybe we can take another questions from the audience. Yeah. So we can take, Naja, we can take one question. Okay. I think this is for Puan Wahi. So from Michael Tan as well, I read in the newspaper that seaweed can reduce methane from cows. Wow, interesting question. Is this seaweed also culture here in Malaysia?
Well, yeah, actually, I know there are red algae, red seaweed that can help in reducing the methane for cow, where we add seaweed in the cow feed. Yeah? Dalam makanan dia, kita tambah rumpai laut. But that kind of rumpai laut, kita tidak culture di Malaysia. If I'm not mistaken, the name is something like asparagopsis. It's a type of red algae. Yeah? But we do not culture it here in Malaysia. But I believe with the addition of seaweed inside the cow feed, it can help, I think, around 40 to 60% of methane reduction in cow, which can help them to, which can help the cow lah. But people also add on liquid inside the cow feed to help methane reduction in cow. So if you don't have that kind of seaweed, we also have other options to help the methane reduction in cow lah. But yeah, there is a kind of seaweed that can use as feed additive.
Thank
for
you,
cow
Puan
feed.
Wahi. Very interesting. I'm not sure. Maybe we can take another question. This is for Dr. Teru. Can HAB make you sick?
Yes, it depends on what species of HAB we are talking about. So if it's those that influence human beings, then most probably they are toxic. And yes, it'll make you sick. And if you consume large amounts enough, it might even cause death.
All right. Thank you, Dr. Teru. Yeah, I think I will take one final question. This will be the last one because we still have 9 minutes before we finish our session today. Okay, the last one is for Dr. Fatiha. And it's on pygmy seahorse, Dr. Fatiha. Can we culture it in the aquarium? Question from Nabila.
Thank you, Nabila. Yeah, all seahorse are possible to be cultured in the captivity. But of course, we need, since as I mentioned just now in my presentation, okay, all pygmy seahorse been listed as a data deficient organism. So we need to conduct more research, okay, to make sure we know the biology, then only we can culture them. Okay, thank you.
Okay, thank you so much. Thank you to all our speakers today. And audience out there, viewers out there, for this 2 consecutive days, we only present you 10 of the research that have been conducted in the Institute. We actually have, I think, 26 academic researchers in the Institute. So if you're interested to know more, please email us and we can give the details. We can give the details about our about the research that we've been doing at the Institute. So thank you so much for being with us. And tomorrow we will have the last session for Ocean Talks. And it will be at 9 to 11 a.m. Yeah, tomorrow morning. And the title will be Amalan Penggunaan Lestari dan Cabaran Pemeliharaan Sumber Pesisir Pantai. So don't forget to be with us tomorrow. And for those who wanted to pursue their postgraduate or their tertiary education with us, the Institute is offering 2 undergraduate program, which is aquaculture and also marine science program. And also we offer postgraduate in master and PhD level. So if you are interested, please do not hesitate. Please contact us. And before I end our session today, I've been waiting to do this, but I kept on forgetting. I will end it with a pantun. Hari ini ada pantun ya. Kalau ada jarum yang patah, jangan disimpan di dalam peti. Kalau ada silap dan salah, jangan disimpan di dalam hati. Dalam norma baharu ini, jika ada pertanyaan, kemuskilan atau ketidakpuasan hati, silalah email dan WhatsApp kami di Institut Penyelidikan Marin Borneo. Terima kasih semua dan jumpa lagi esok. Bye.
Chase the moon and sun when I'm with you. Give it all away. Catching fire as the river. I'll never let you love the pride. I see $1 billion in your eyes. Even if we're strangers till we die.
Ya Allah, habis lu ah. Allah,
Cakap hai. Cakap okey nak makan siapa? Oh. Oh. Irawati harapan bangsa. Wow. Okey ya.
lepas.